Hello everyone, welcome back to our Algebra 2 class. Today we are going to continue our conversation about sine and cosine function. In the previous class, we gave the definition for sine and cosine. And if you do remember, sine in the unit circle, do not forget, it really depends on what kind of circle we're dealing with. If this is unit circle, it's y, and cosine theta is x. And x stands for the terminal ray, where the terminal ray of the angle intersect with the unit circle, and x is the coordinate of the point, and y is the y coordinate of the point. And also theta here is the angle. So today we are going to use this definition and extend this to create a graph of the sine and cosine function. And just to let you know, unfortunately, because the arrangement for this year, we cannot go deeper for this function. There is actually a lot of interesting topics about these functions, about these graphs. We can do so many things about it, but unfortunately, we can only introduce so much about this topic. So please check this into this. But if you are interested, you can always, do some research on your own to figure out, this interesting function to know more about this. Okay, so let's start the lesson today. So since we are going to define these two functions, we are going to actually give the graph of these functions. So the first thing, we are going to create a table, like the list of the values of the x, and figure out the y value. Like when we graph the function, we need to use like a plot points. So the first thing, we are going to create the points. And we are going to use a unit circle to help us to finish this, to complete this table in order to get a point of the graph. So that's why I put the unit circle here. So let's quickly check, what kind of function we are going to look at. So today we are going to look at the function of y equal to sine x and y equal to cosine x. So x here, as you can see, is actually is always independent variable, which is the input, and y, of course, is output for this. So this one, the x here stands for the angle, and y is a value of this sine x here. So just like what we did, last time, like sine 30 degree is what, sine 90 degree is what. This is what we do. So we're going to use this unit circle to finish the table first, and then we are going to plot these points on the graph. So we'll see the basic structure of both functions. So let's check the first one. The angles we are going to have here is from negative 2 pi to 2 pi. So we go counterclockwise a circle, and then and also clockwise for this. So we are going to use this one to finish. So sine, for example, let's see this. When x equal to 0, meaning the angle is 0. So cosine 0. Cosine 0, do not forget, cosine theta is always the x coordinate of this point. So that's why cosine 0 is 1. And then cosine pi over 2, which is 90 degree. So if you check this point, which is 0, 1, so it's going to be 0. Then cosine pi is going to be negative 1, 0. This is the coordinates. So then we are going to only choose x value here, which is negative 1. And this negative 3 pi over 2 is going to be 0. Then 2 pi go back again, it's going to be 1. So if we go counterclockwise, you will see the exactly same thing. But remember, we go actually clockwise this. So negative pi over 2 same as 3 pi over 2, so it's going to be 0. Negative pi same as pi, so it's going to be negative 1. Negative 3 pi over 2, which is pi over 2, so it's going to be 0. And again, no matter it's negative 2 pi or 2 pi, we'll go back to where is the 0 degree located, is 1. So that's for cosine x. And then let's finish the table for sine x, so we can use a table to create the whole graph of this. For sine theta, do not forget, for sine theta, the definition for sine theta is the y coordinate. So this time we are going to only looking at the y coordinate. Again, starting with 0 degree, so it's going to be 0. Pi over 2, which is 1, because the y coordinate for this point, if you look at here, is 1. And then for pi, it's going to become 0, 3 pi over 2, negative 1, 2 pi, excuse me, it's going to be 0. Then we just clockwise to see the angle, but you will see it's actually repeating. So negative pi over 2, same as 3 pi over 2, it's going to be negative 1. Negative pi is going to be 0. Negative 3 pi over 2, which is pi over 2, same as that, which is going to be 1. Then negative 2 pi will go back to 0 degree, so it's going to be 0. Okay, so with this table, we are going to create a graph here. Let me change to a little bit bold so you can see. So same as, we are going to use a blue color to stand for the graph for the cosine x, and we use a red color to stand for the sine x, okay? So as you can see, for the x part, I use the radian angle here to represent value here. So some student might say, why don't you use 360 degree or 270 degree? First of all, they are equivalent. Second of all, in order to get, more, what do we say this? Like reasonable graph, we prefer to keep the x and y more reasonable to that. So that's why when we do this, we keep the radian angle here instead of using, the degree here, like 100 degree, then the scale between y and x will be a little bit off. So that's why we prefer to keep this way. And also, as you can see, all the values here is they're now go beyond 1 or negative 1. So I'm going to set up this point as 1 and this point as negative 1. So let's graph both functions. Let's graph the cosine x first. So the very first thing, let's see. I always start with 0. So when x equal to 0, this is 1. When x equal to pi over 2, it is 0. When x equal to pi, it is negative 1. And then 0, then 1. So some student might say, am I going to connect this like a V part, or this is going to be just points? First of all, it will continue this. So that's why there's actually values between that, but the special angle we mentioned here will help us to give some special value for this one. So that's why I'm going to use this point to give us a basic structure, and when I connect them, I'm going to make sure this is a very smooth curve. Well, I'm not so good at drawing, but you get a point. Like a curve V, right? So we are going to move on to finish the left side of this, and you will see it's actually continuing, right? It's like a wave, but it's like a continuing move on the wave. So sometimes if you do not think you are going to connect them in a beautiful way, just connect them piece by piece. Okay, so this is y equal to cosine x. Now let's move on to the sine x, and later we're going to do a very brief analysis for this graph, okay? So for this one, we still focus on these values here. So we are going to plot the points first. When x equals 0, it's going to be 0 here. Focus on the red part right now. Then pi over 2 is 1. Then it's 0 again, then it's negative 1, then it's 0. I just, plot this y value here on the graph, and then I'm going to connect them. But when you connect them, again, please make sure it is a very smooth curve. Again, it's like a wave, right? So that's why I'm telling you, this is actually a lot of, interesting thing about these functions here, but very unfortunate we don't have enough time to finish that. Anyway, so let's continue for the, for the left side, we just, plot the points. So now I'm going to connect them. Again, forgive my a little bit messy drawing. It's not so bad. So this is going to be y equal to sine x. Okay, now look at these two waves here. You probably notice that it's like, repeating pattern, right? I can just keep going forever if I want to go beyond these angles, and you are right. It will go forever. And just because it's repeating a pattern, these two functions actually called periodic function. Again, we actually have so many topics about this topic, but very unfortunate we cannot go beyond that. But anyway, so this two function is periodic. You can just know this name, but you want to do more research on your own, go for it. So this is a periodic function because it's repeating the pattern here. That's one thing. Another thing, as we can see, if you just check the wave for both blue and red functions here, the highest value is actually 1. And the minimum value is like the very bottom value of the function is actually -1. That meaning the range didn't go beyond the value here. The lowest is 1, the highest one is 1. The lowest one is -1, the highest is 1. It's for both functions. Of course, if I write it in a different way, probably I'm going to create a different function, but for cosine sine x is like that. And there's actually a lot of things we can introduce about periodic function, but I guess this time you are going to do some research on your own if you are interested. So this is just, very basic graph for you to see. This is actually two waves for this two function, right? It's quite different from the function we had before. And if we just continue this pattern, you will see just very long wave for that. Okay, so in the next video, we are going to actually use Desmos online graphing calculator to get more different kind of graph to have more sense of, what is changing and how does it change when we write in different kind of function. So I'm going to see you in the next video, and thank you so much for watching this video and study this topic with me. See you soon, everyone.